All right, these are 10A notes. Notice we're going back to chapter 7 and looking at more exponential growth and decay with application problems. So we have two formulas we're going to be using first. A growth model, notice it's 1 plus the rate, so it's growing, and a decay model, 1 minus the rate. All right, now A stands for the initial amount, R is your rate of change, and T is time in years. So be careful about this. It must be in years. So if the problem gives it to you in months, you must convert it to years. All right, let's look at our first example. In the last 12 years, an initial population of 38 buffalo in a state park grew by about 7% per year. About how many buffalo were in the park after 7 years? All right, first thing we want to do is make our model, and then we'll go through and answer our questions. So notice I underlined the word grew. So that means this is a growth model. All right, so our initial amount, our initial population of buffalo was 38. So A is 38. Our rate of change is 7%, so we've got to use that as a decimal. And our time, eventually, like I said, we want it after 7 years. Let's write our model first. Let's write our equation so we can use for any number of years, and then we'll make our prediction for 7 years. All right, so our formula, y is equal to A times 1 plus r to the t. All right, plug in what we know. So y is equal to 38, our initial amount, times 1 plus our percentage to the t. So our model, when we clean it up, is y equals 38 times 1.07 to the t. That's your model. Okay, now that 1.07, that's your growth factor, and the percent of increase would be that 7%, would be your percent of increase. All right, now let's make a prediction. So how many buffalo were in the park after 7 years? So all I'm going to do is take my 7 and substitute it into my formula. All right, do that math, and we get 61.020. Well, we can't have a fractional part of a buffalo, so we have approximately 61 buffalo. All right, they ask us to graph the model and use the graph to estimate the year when there are about 53 buffalo. So we know that there are 53 buffalo, so y is going to equal 53. We're working backwards and trying to find time. So we're going to use our calculator for that. All right, I'm going to show you that now, but I will also go over this in class. So on your calculator, you want to graph our original model. Now we're going to, instead of a t, we're going to put an x instead of t. So we're going to have 38 times 1.07 to the x power. All right, hit enter. Remember, we're going to have to zoom out. All right, we want it to graph also y equals 53. So we're going to hit tab and type in 53 and also hit enter. All right, so we're going to need to zoom out so we can see both of our graphs. So let's go to menu, window, zoom out, and we're going to zoom over here until we see where they intersect. Okay. So what we're looking for is where our horizontal line intersects our exponential curve. So remember, that's menu, analyze graph, intersection. You want to left bound it, right bound it until intersection pops up. Hit enter. All right, so we're interested in our x variable, so our 4.92. So back on our problem, so in approximately 4.92 years, we expect to have 53 buffalo. All right, like I said, I'll go over the calculator part of this again in class, but it's very similar to what we did when we were doing regression. All right, let's look at another example. All right, television. The new television costs $1,200, so that's going to be our initial amount. That's our A. The value of the television decreases by 21% each year. Write an exponential decay model giving the television's value in dollar after t years. All right, let's do our model. So they told us it was decay. So y is equal to a times 1 minus r to the t power. Plug in what you know. All right, so we got y is equal to our initial amount, $1,200, what we paid for the TV, 1 minus our percentage, change it to a decimal, to the t power. All right, let's clean that up a little bit. So we're going to have y equals 1,200 times 1 minus 0.21 is 0.79 to the t power. All right, that's 79%. That's our decay factor. And the percent of decrease is that 21%. These questions are going to come in later, so that's why I'm going over that vocab now. All right, let's make a prediction. Estimate the value after 2 years. So that means t is equal to 2. So you're going to plug 2 in for t and evaluate that. So I'm getting, this is money, so we're going to round to 2 decimal places, $748.92. That's how much my TV is worth after 2 years. All right. Yes, let's graph the model. We'll do that in a second. Use the graph to estimate when the value of the television will be $300. So here again, we know what y is. We're looking for time. So we want to graph both our models and see where they intersect. So back to the calculator. So I'm going to new screen. All right, let's graph our model. So 1,200 times 0.79. I'm going to change that t to an x. Whoops, going to raise it to a power. So caret x. Hit enter. All right, tab. And we want to know when it's worth $300. All right, we're going to have a lot of zooming to do. So we're going to go menu, zoom. You could do zoom fit. You could try zoom fit here. I'm going to zoom out just so we're going to zoom out a bunch. Going to get that y-axis. There we go. Looking for where the two intersect. All right, let's find that intersection. So we got analyze graph, intersection, left. Oh, let's try that again. And then move it right till then it says intersection. Okay, so we're looking at 5.88 years. And I typically don't round my years because that's a partial year and we can have that. That makes sense to us. Okay, so back on my screen, on my notes. So I estimate that in approximately 5.88 years, the TV is worth $300. Okay, doesn't hold its value very well. All right, so those are 2 examples of exponential growth and decay problems. Let's look at now example of compound interest problems. All right, so notice our formula. A, which stands for an amount, is equal to P, which is our principal, how much money we put in, times 1 plus R, which is our rate, annual rate, divided by N. This is how many times they compound that interest. All raised to the n times t power. T is here again, and it must be in years. So be careful for that, because that's kind of a getcha thing. All right, so let's look at our first problem. You deposit $2,900. So $2,900 is your original principal. That's P. An account that pays 3.5%. That's your rate. Annual interest. Find the balance after 1 year. So that's my T. If the interest is compounded monthly and annually. All right, let's look at A. That says compounded monthly. Well, there are 12 months in a year, so that means N is 12. All right, so let's let's make our formula. So A is equal to my principal, $2,900, times 1 plus my rate. Always change it to a decimal. Okay, so 0.035 over n, which is our 12, all raised to the n times t, so 12 times 1. And that's what people forget, is that exponent you have to raise it to. All right, take a moment, put that in your calculator. Here again, where we have money, so we're rounding to 2 decimal places. So that means we're going to have $3,003.14. Okay, let's compare that with B, with interest compounded annually. So that means n is equal to 1. All right, so they're only going to figure our interest one time a year, which is A. They're going to figure it 12 times a year. Okay, so let's figure that out. So A is equal to 2,900 times 1 plus my rate again, over 1 this time, and then n is 1, and after 1 year is 1. All right, here again, take a moment, put that in your calculator. And we're getting $3,001.50. Okay? All right, so compound interest. All right, let's look at one more of these. You deposited $5,500 in an account that pays 3.6% annual interest. Find the balance after 2 years if interest is compounded monthly. All right, so take a moment and define all your variables that you need. Your P, your R, your N, your T. I'll give you a head start on that. All right, so let's do our P is 5,500. Our rate is our 3.6%. Our time is 2 years. And compound it monthly, so N is 12. All right, so let's make our formula. So A is equal to our principal times 1 plus R over N to the NT. So let's plug in what we know. We know 5,500 times 1 plus our rate over N, which is 12, to the 12 times 2, N times 2. All right, put that in your calculator. Here again, round to 2 decimal places. So I'm getting $5,909.97. All right. Now, notice that these are, we're going to look at a different type of formula now, which is called continuously compound interest. So when interest is compounded continuously, the amount A in an account after T years is given by the following formula. So A is equal P e to the RT. I'll call this my PERT formula, where P is the principal, and R is the rate. So principal is when it's compound continuously, principal is constantly earning interest, and the interest keeps earning on the interest earned. So you keep earning all the time. So you add a little bit to your money and you keep earning. All right, so let's look at this formula. You deposited $3,500, so that's your principal, in an account that pays 4%. That's your R. Annual interest compounded continuously. So that's telling you we're going to use PERT. Notice we don't have an N in this problem. And what's the balance after 1 year? So T is 1. All right, so our amount is equal to our principal, E to the R times T. So R is still got to change it to a decimal, times our time, which is after 1 year. All right, and you literally want to put that in the calculator with E. Don't put this as 2.7. You actually want to put it in the calculator with E. So let's do that with the calculator real quick. So you want to be on the calculate screen. So you're going to have your 3,500 times E to the 0.04 times 1. Hit enter, and that's how much money you're going to have. Okay, so that's going to give us $3,642.84. All right, let's look at one more example. You pay $3,500 in an account that pays, you deposit $3,500 in an account that pays 4% annual interest compounded quarterly. What is the balance after 1 year? All right, so here you're going to decide which formula you're going to use. You're going to use PERT or you're going to use the other formula. And how can we tell the difference? Well, hopefully you notice this says compounded quarterly. It doesn't say compounded continuously. It has to say compounded continuously to use PERT. So that means our N here is 4 because we're compounding quarterly. So we're going to use this formula. If we have an N, we need the formula with the N in it. All right, plugging and chugging time. So A is equal to our principal times 1 plus our rate. Here again, change it to a decimal. Over N4 to the N T, and we're after 1 year, so T is 1. All right, so do this math in your calculator. Put that in, and you should be getting $3,642.11. So notice we were making a little bit more money when we compound it continuously, but not a tremendous amount of more money. Because like I said, the amount of increase is so minor. That's why you're not, your money's not growing greatly because of that 4% interest. All right, if you have any questions, please ask when we talk in class.